Welcome learners for the lecture 5 of a cosmology. Today we discuss about the test particle of a motion. Okay, you know that we considering to the de Sitter model of the universe or as well as to the Einstein model of the universe. Okay, they will be considered as a four type. They generated as a three type will be considering, that is a 3C will be denoted test particle motion. In a previous lecture, we consider as a 2D as a form that will be generated as a all detailed information giving to the form. Okay, next topic will be considered, that is a test particle motion. Let us go start it. The trajectory of the test particle is the time like geodesic. Okay, you know that all the form of the consideration of a equation, that is a x double dash p plus gamma consider as a mmp x dash m into x dot n equals to 0, where x dot m equals to dx to the power m upon ds. This will be considering as a equation 3.12. 3.12 means in a three form of the de Sitter as well as the Einstein universe model, they generated as a particle. Okay, hence it will be considered as a 3.12, because all detailed information giving in the previous lecture for giving as a 3.1, 3.2, which equation will be given. Okay, then consider a particle which is temporarily at a rest with respect to special coordinate. If suppose that given to the form r dot theta dot equals to phi dot equals to 0, they will be considered as a equation. Then put up to the value of a equation 3.12. How to get it as a value? Then they generated to the value x double dot p plus gamma p considering as a 4. If we generated to the value 4 x dot 4 whole square, because both of these value given as a equation, okay, equals to 0. Then given to the equation, that is a gamma p 4 equals to 0, means a p equals to 1 to 3 get it as a value, because last value given as a form, that is a, then hence the above equation become x double dot p, they generated to the value, that is a equation will be considering x double dot p equals to 1 2 3. Okay, then spatial acceleration of the particle is a 0. They considering to the form, if the particle is temporarily at a rest. Suppose that some particle is temporarily, not a permanently, it is temporarily at a rest, then it will be the rest permanently, hence it will be become to the rest permanently. Okay, this will be the 3 point test particle, which means the spatial acceleration of the particle is 0. If the particle is a temporarily rest, then it will be considering as a permanently rest. Okay, this is the test particle motion. Let us go next topic, that is a 3D Doppler shift. Okay, this is a exam wise, it is most important part, because always question asked in this part. Doppler shift. Consider a source, that is a 0 equals to minus 1 minus r square upon capital R square to the power minus 1 dr square per dt square. You know that dr upon dt equals to plus minus square root of a 1 minus r square upon capital R, and t1 and t2 give the above equations give to the value, that is the integration will be generated t1 to t2 dt minus integration generated t1 to t2, because value will be given in the both of this form, that is the t1 and t2 dt minus integration r to 0 or 0 to r getted as a value dr upon square root of a 1 minus r square dr square. Okay, since r is a decreasing, there is a negative sign, then t2 minus t1 equals to r sine inverse r by capital R. Okay, this will be getted as well. You know that in a derivative, partial derivative form will be considering, then its value will be generated delta t2 minus delta t1 equals to 0, that is the delta t2 equals to delta t1. Put up to the value, time interval between the receptions of the two successive wave is equals to time interval between their emission wave. Moreover, for the observer at a rest with respect to spatial coordinate, that is dr equals to d theta equals to d phi equals to 0 for the line element giving to the equation. Okay, that is the equation 2.3. You know that ds square equals to dt square, that is the ds equals to dt also. Coordinate time in a proper time s will be given. Then equation 3.14, that means considering to the equation that means the considering equation, that is a 3.40 delta t2 minus delta t1 equals to 0, means given to the equation 3.14, that is a delta equals to delta t1, means a proper time interval of a reception of a two successive wave at a r equals to 0 is the proper time interval between their emission of a wave, that is the r equals to r will be generated. There is a no change in the wave of the light, no change in that form. There is a no Doppler shift and hence a no rate shift occurrence. This will be given to the form. Okay, this will be if we get it as a emission of a wave, will be comparing two successive wave as a emission wave, then there is a no change in the wavelength of the light, there is a no Doppler shift as well as a no rate shift occurrence. This will be generated. Next part, that is a 3e, comparison with the actual universe, means a 5 part will be given in this form, that is a comparison with the actual universe. You know that actual universe model will be given as the Einstein model. Okay, you know that all theory of the cosmology generally perfectly apply to the general relativity of the form, that is a Einstein. This Einstein theory is mostly used in all part of the equation will be generated, because they will be properly updated or the uploaded or the you get it as a form, that is a perfectly match in the any equation of the form, hence their value will generally uses in the form. Okay, hence it a comparison with the actual universe of a Einstein equation, because this is a model will be given as a Einstein equation form. Okay, Einstein model provide a finite distribution of a matter, which is an observation fact in actual universe. If gated as a, that is a rho equals to 10 to the power minus 30 gram centimeter minus cube for a incoherent matter. The radius of a Einstein universe R equals to similar to 3.5 into 10 to the power minus 30 light years. This is an upper limit for the radius of the observable universe. Okay, this will be for the most unsatisfactory features of the Einstein model is that it does not predict any systematic Doppler shift for the light coming from the distant galaxy. The most unsatisfactory features of a Einstein model that it does not predict any systematic Doppler shift of the light coming from the distant galaxy. Means if uses as a galaxy, they are the getting as a light in the Einstein show the model that will be the galaxy light persisting about the um, Earth as well as other planet. They does not get it as a Doppler shift for the light coming from the systematic form. Okay, this will be the comparison with the actual universe with a